Okay, good day. This is Free Calculus. I am Mr. McCulley, and this is the video presentation for lesson 47 on inverse matrices. Let's get to it. So this is goals. This is a supplemental. It's not necessarily in the book, but we are going to talk about the inverse of a square matrix. So we're going to, by hand, um, find the inverse of a 2 by 2 matrix, and then we're going to use a graphing calculator to find the inverse of a 3 by 3 matrix. And then we're going to review using matrices to solve systems of linear equations, and that's one use of matrices. That's more of an algebra use of matrices. There are many, many more uses of matrices in statistics. But first, definition in linear algebra, a square matrix A has an inverse if and only if. If you take A and multiply it by its inverse B, you'll get the identity matrix. And the identity matrices for 2 by 2 and 3 by 3 matrices are as follows. So basically, any identity matrix for a square matrix will be a 1 down the diagonal and zeros everywhere else. So 1 down that diagonal from the top left-hand side to the lower right-hand side is how you're going to have that inverse or the identity matrix. All right, so the formula for calculating inverse matrix of a 2 by 2, which we're going to do by hand, you're going to be asked to show by hand, is if you have this matrix A, B, C, D, it's a 2 by 2 matrix, then its inverse, and remember, you denote inverse with this to the -1 power looking thing, this superscript that's -1. And it's found by going 1 divided by the determinant of whatever A was, which is what we learned in the last section. And then you take the A and the D and you switch them. You leave the B and C at the same place, but you make them negative. Now remember, the determinant is AD minus BC for a 2 by 2 matrix. And so you could also just skip the determinant part and go AD minus BC. All right. So let's do an example of that. And so here is our given matrix, and we want to find A inverse. So the A inverse matrix of this one is going to be equal to 1 over the determinant. Now remember, the determinant is the AD minus the BC, so it's going to be 1 times 3 minus the quantity, -2 times 2, and then again, we're going to follow that definition that we had on the last page, where we're going to take the A and the D and we're going to switch them, and then we're going to leave the B and the C alone and make them negative. All right, so the A and the D have to switch, so the 3 goes there, the 1 goes there. This 2 in the B position becomes -2, and this B here, or this C here, and becomes negative. So negative of a negative would make it positive. So we're going to just calculate that. So I've got 1 over 3 minus -4. So 3 plus 4 would be 1 over 7. And when we multiply any matrix by a scalar, all we have to do is multiply each value times the scalar. So we'll have 1/7 times 3. We'll have 1/7 times -2. We'll have 1/7 times 2. And then we'll have 1/7 times 1. And that will leave us as our final answer 3/7, -2/7, 2/7, and then 1/7. And you'll notice just by the definition of this matrix here, we're probably, and this 1 over the determinant, we're probably going to get a lot of fractions, excuse me, when we find inverse matrices. All right, so if we want to use the graphing calculator to find the inverse of a matrix, well, here is a 3 by 3 matrix that we're going to find the inverse of. So we're going to clear out what we had there, and remember, when we want to do matrices, it is this button right here that is 2 up and 1 to the left from the 7 button. So I'm going to hit the second value and then the matrix to bring up the matrix. I've already got a 3 by 3 matrix there. So I'm going to go over to edit. We're going to edit C. Excuse me. Sorry about that. Anyway, so again, we want it to be a 3 by 3, so we're going to hit enter for both of those. And we get those rows. So it's 1, -2, 1. So 1, -2, and then 1. And then let's see here. It was -1, -1, 2, or -1, +1, 2. So -1, +1, and then 2. And then that last row, 3, -1, -1. Come on, go back. 3, -1, -1. And we just want to find the inverse of that. So we're going to quit out. We'll go second, we'll go matrix. We'll stay in names now because we want to do some operations on that. We're going to hit 3 for C. Then we're going to have that X inverse button. And we'll hit, just to be safe because it's probably going to get fractions, we'll go math, hit 1 for fraction, hit enter, and there is our solution. So let me scooch this over here. And, oh, come on, let me do it. I'll write it down right here, maybe. Oh, come on. The inverse of this is going to be, well, I have 2 screens, so I'm going to put it up on my other screen so I can copy it. It is -1 over, a humble brag, by the way, I've got 2 screens. 3 over 11, 5 over 11, -5 over 11, 4 over 11, 3 over 11, 2 over 11, 5 over 11, and then 1 over 11. It's not the neatest one of all time, but there you go. All right, so an application that we have seen before. One use of inverse matrices is to solve systems of linear equations. So senior classes at high school A and high school B plan separate trips to the indoor climbing gym. The senior class at high school A rented 7 vans and 11 buses filled with 720 students. High school B rented and filled 14 vans and 9 buses with 738 students. Each van and bus carry the same number of students. Find the number of students in each van and bus. So remember, this sentence here tells us what the variables are. And so our variables are going to be V is the number of students in a van, and then B will be the number of students in a bus. I don't need 2 S's, I just need 1 S, B-U-S. There we go. All right, so the first one here, if I go 7 times the number of students in a van, I'll have the total number of students in vans, so 7V plus, and if I multiply 11 times the number of students in a bus, I'll have the total number of students in buses, so 11 buses, and we got 720 students there. And then for 14 vans and 9 buses, they ended up with 738. And so clearly we can set up a system of matrices where our coefficients matrices will be 7, 11, 14, and 9. That's a 14. And then my constants matrix will be 720 and then 738. And we'll go A inverse B. And then that result will be V and B. So let's grab that graphing calculator again. You got to bring it back over. Sorry about that, folks. All right, so second, with our matrix, we're going to go over to edit. We want to edit that 2 by 2 matrix to start. So hit enter twice again, and then it'll be 711, 711, haha, 14, and then 9. We're good there. We'll quit out of that, go back into matrix. We'll go back over to edit. We'll edit that second matrix. We need it to be a 2x1 and 720 and 738. So 720, 738. Hit enter there. Okay, we're going to quit. We want to do second matrix. We're going to stay in names because we want to bring that up. We want the inverse of that. And then second matrix, we'll hit 2. We'll hit enter. And so it looks like 18. So got 18 and 54. That's a pretty big stinking van. So 18 students per van and 54 students per bus. All right, well, that's all I got for today, folks. So, the Star Wars fun fact of the day, Star Wars Attack of the Clones, which was in 2002, was the first time that a Star Wars movie was not the highest grossing movie of the year. It's not the last time it happened. Just think about Solo. It lost money. It was actually third that year behind both Lord of the Rings and Spider-Man, the Tobey Maguire 2002 movie. Well, that's all I got. So have a good day. Bye.